In this question, they have given that in a triaxial unconsolidated undrained test. So triaxial unconsolidated undrained test, where which means for unconsolidated undrained test, the angle of internal friction will be equal to 0. Okay. On a saturated clay sample, the cell pressure, they have given the cell pressure, just sigma 3. It is 100 kilopascal, and if the deviatoric stress at failure, so they have given the deviatoric stress as 150 kilopascal. They are asking us to find out the undrained shear strength. Okay, so from this we can get sigma 1 will be equal to sigma 3 plus sigma d, which is nothing but 100 plus 150, 250 kilopascal. Okay, so from the stress relationship we can get sigma 1 will be equal to sigma 3 tan square 45 plus pi by 2 plus 2c tan 45 plus pi by 2. Since pi equal to 0, we get sigma 1, we can directly substitute here. Sigma 1, that is 250. Sigma 3 will be equal to 100 tan square 45 plus 2c tan 45. So from this equation, we can get C, the value of cohesion as 75 kilopascal. So the equation of shear strength will be equal to tau, which is nothing but C plus sigma n dash tan pi. Since the value of pi it is 0, then this part will be neglected. Therefore, tau will be equal to C, which is nothing but 75 kilopascal. In this question, they've asked us to match the following. If you see the point P, in a triaxial compression test with increase of axial strain in loose and under drained shear condition, the volumetric strain. So in loose and under drained shear condition, with increase of axial strain, the volumetric strain will always decreases. So if coming to the point Q, in a triaxial compression test with increase of axial strain in loose and under undrained condition. So it is undrained condition, since the excess pore water pressure will get increases due to increase in axial load. Okay. So in a triaxial compression test, the pore pressure parameter B for a saturated soil, which is always 1. For a shallow strip footing in pure saturated clay, there is a case bearing capacity factor due to surcharge. So for clay, NQ will be equal to 1, NC will be equal to 5.7, and N gamma will be equal to 0, where pi equal to 0. So from this we can get NQ is always 1. In this question, they have given that a direct drain shear test was carried out on a sandy soil under normal stress, which is sigma n, that they have given us 50 kilopascal. And the test specimen failed at a shear stress of 35 kilopascal. So they have given the shear stress. They have asked us to find out the internal angle of internal friction. So since the test has been conducted in sandy soil, the value of cohesion will be equal to 0. So from the shear stress relation, tau will be equal to C plus sigma n tan pi. So since C is equal to 0, 35 will be equal to sigma n, which is nothing but 50 tan pi, which gives tan pi, it is 0.7. By solving this, we get pi will be equal to 35 degree. In this question, they have given that an unconfined compression strength test was conducted on a cohesive soil The test specimen failed at an axial stress of 76 kilopascal. So the specimen failed at an axial stress of 76 kilopascal. And they have asked us to find out the undrained cohesion. Sigma 1 will be equal to sigma 3 tan square 45 plus pi by 2 plus 2c tan 45 plus pi by 2. So, since the test is unconfined compression strength test, the value of sigma 3 will be equal to 0 and the value of pi will also be equal to 0. Therefore, sigma 1, which is 76, will be equal to 2 into c tan of 45 plus 0. Therefore, c will be equal to 76 by 2. So, tan 45 will be equal to 1, which is nothing but 38 kilopascal. In this question, if you draw the stress bar diagram of this, we get that. So this one will be equal to sigma V is major principal stress, whereas sigma H will be equal to minor principal stress. So sigma H, sigma V, sigma V dash. And so this is sigma H, sigma V dash, sigma V double dash. So if you see the graph, sigma V is increasing and sigma H is constant. Option A is the right answer. In this question, they have given that a consolidated drain triaxial test was carried out on a sand sample with known effective shear strength parameters C dash equal to 0 and phi dash equal to 30 degree. So in the test prior to the failure, when the sample was undergoing axial compression under constant cell pressure, the drainage valve was accidentally closed. So the drainage valve was accidentally closed. At this time, the deviator stress developed was 360 kilopascal and core water pressure will be 70 kilopascal. So they are asking us to find out if the test is repeated without such error and no back pressure is applied, what will be the deviatoric stress at the failure. So they have given C dash is equal to 0, phi dash will be 30 degree. Also during the closure of valve, sigma D will be 30 kilopascal and U will be 70 kilopascal. Write down the solution. So sigma 1 will be sigma 1 dash will be sigma 1 minus u, whereas sigma 1 will be equal to sigma 3 plus sigma d. Therefore, sigma 1 dash will be equal to sigma 3 plus sigma d minus u. Also, sigma 3 dash will be equal to sigma 3 minus u. Sigma 1 dash will be sigma 3 plus sigma d, which is nothing but 360 minus u. So plus 360 minus 70 will be plus 290. Also sigma 3 dash will be sigma 3 minus u, which is nothing but 70. Okay. So from the stress relationship, we know that sigma 1 dash will be equal to sigma 3 dash tan square 45 plus pi by 2 plus 2c dash tan 45 plus pi by 2. So here sigma 1 dash is nothing but sigma 3 plus 290, where sigma 3 dash is nothing but sigma 3 minus 70 tan square 45 plus pi by 2, which is 45 plus pi, it is nothing but 30 by 2 plus 2c. So here they have given this c dash as 0. So this part will become the 0. Okay. So with this, we can calculate the value of sigma 3 which is nothing but 250 kilo Pascal. Okay. Now if the test is repeated without the closure of drainage wall, we need to find out the value of sigma d. So now we have found out the value of sigma 3. So with this sigma 3 we are going to find out the value of sigma d, which is nothing but now sigma 3 plus sigma d will be equal to sigma 3 minus 70 tan square 45 plus 30 by 2. So we have got the value of sigma 3 which is 250 plus sigma d which is 250 minus 70 tan square 45 plus 30 by 2. So from this we get the value of sigma d as 500 kilo Pascal.